is we're looking at the transformations of the parent graph, which is the square root of x. The square root of x graph starts at 0, 0, and it goes over 1, up 1, back to 0, 0, over 4, up 2. So what you can do is you can look at these transformations. You'll notice that underneath the square root it says x minus 2. So that means the graph is going to shift right 2 units. And then this value right here indicates that the graph will shift up 3. So we're going to move that original point 0, 0. We're going to go right 2 and up 3. And then from here we're going to use the pattern where you go right 1, up 1. And then you go back to this point and you go right 4, up 2. And so here is your graph. We have f of x equals negative square root x. And the negative in front indicates that the graph is going to reflect across the x-axis. The first point on the graph is still at 0, 0. And then instead of going right 1, up 1, right 4, up 2, we're going to go right 1, down 1, right 1, 2, 3, 4, down 2. The next problem is f of x equals the square root of x plus 4 and then minus 2. But the graph is going to shift left 4. And then the number at the end indicates that the graph is going to go down 2. So let's go ahead and move that initial point 0, 0. We're going to move it left 4 and then down 2. And there is not a reflection across the x-axis, so there's no negative in front. So your graph is going to follow the same pattern of right 1, up 1, then go back to this point right here, and we're going to go right 4, up 2, and you get this graph. For problem number 5, you can see that the graph has moved right 2 and down 2. So what we're going to do is to indicate the movement right 2, we're going to go x minus 2. So inside the square root, you're going to use the opposite. It's going right 2, so you do x minus 2. And then it's moving down 2, so then at the end we're going to go down 2, so we're going to write negative 2. So there's your function for number 5. And then finally, number 6, we have two things that happened. First, the graph has been reflected across the x-axis. So anytime you have a reflection across the x-axis, you're going to put a negative in front of the square root. And then the graph has also moved left 4. So since it's a left 4, we're going to go x plus 4 underneath the square root. So there's your function. Number 7 says, describe the transformations of g from the parent function f of x equals the square root of x. So you have two things happening. First, you have the value in front, which is 1/2. So that's going to be a compress vertically. Any values in front of the square root are going to be vertical compressions or stretches. And also we have by a factor of, and it's going to be 1/2. And then it's asking for whether the graph is translating up or down. So at the end you have the plus 4, so that means it's going to go up by 4. Number 8 says describe the transformations of g from the parent function f of x equals the square root of x. And here's your function for g. It says negative 4 square root of x minus 2 and then minus 5. So we have a stretch vertically because of the number being on the front of the square root, and it's by a factor of 4. You also have a reflect across the x-axis because the negative is in front. And then finally we're going to translate down by 5. That's because the number at the end is a negative. And then we're also going to be moving right by 2. For number 9, it says describe the transformations of g from the parent function f of x equals the square root of x. And g of x equals the square root of 5 times the quantity x minus 3. So if you'll notice there's a 5 underneath the square root, that means we're now going to have a horizontal compression. Because it says 5 and the number's underneath the square root, that means you're going to actually do the reciprocal. So when you take 5 and put it over 1, then the reciprocal is going to be 1/5, and so that's what your horizontal compression is going to be. And then finally you have the x minus 3, so that's going to be a right shift by 3 units. For number 10, it's a similar problem. This time you have g of x equals the square root of 1/3 times the quantity x minus 4, and then on the very outside it says plus 7. So the 1/3, again, because it's underneath the square root, it's going to be a horizontal stretch, and then it's a 1/3, and so what you do is the factor is going to be the reciprocal. So instead of 1/3, the factor is going to be 3, and that's because, again, it's underneath the radical. Next, you have a translate up because it's a positive 7, so that's by 7. And then finally, we have a left by 4. Next, we're going to graph cube root graphs. So we have f of x equals the cube root of x plus 2. So the first thing is we're going to have a shift that's going to go left 2 units. So we're going to take the 0, 0 point and we're going to go left 2. And then with the cube root graph, it follows the pattern that you go right 1, up 1. Then you go back to that original point and you go right 8. 1, 2, 3, 4, 5, 6, 7, 8, up 2. And so to the right, the graph looks like this, and then in the other direction, you're going to go left 1, down 1. Then you go left 8, down 2, but it's off the graph. So we're just going to head in that direction. So there's your graph for number 11. For number 12, same thing, it's a cube root graph, and then the only thing that you have from the parent graph is you have this reflect in the x-axis. So we'll start off with the point 0, 0, and then instead of going right 1, up 1, we're going to go right 1, down 1, and then we're going to move right 8, 2, 4, 6, 8, down 2, and then in the other direction we'll go left 1, up 1, and left 8, up 2. We're just moving down 4, so we'll take that middle dot 0, 0 and go down 4. And then from there, it follows the same pattern. You go right 1, up 1, and then back to that middle dot, and you go right 8, up 2. And we'll do the same in the other direction. We'll go left 1, down 1, left 8, down 2. For number 14, we're going to write the equation for the given graph. This is the cube root graph that's been shifted up 4. So we're just going to write the cube root of x, and to indicate that it's moving up 4, you're going to put a plus 4 at the end. For problem number 15, you have your cube root graph that's moved right 4, and it's been reflected across the x-axis. So we're going to put a negative in front, cube root of, and then again, because it's moved right 4, we're going to go x minus 4. It says describe the transformations of g from the parent function f of x equals the cube root of x. So g of x equals the cube root of x plus 5 and then a minus 12. So we have a horizontal shift, and it's going to be, because it's a positive 5, we're going to go 5 units left. And then at the end we have a shift that goes down 12. So we're going to circle down, and then it's 12 units. For problem number 17, we have g of x equals negative 1/9 cube root of x minus 2 plus 10. So in front you have your value 1/9, and so that's going to be a compress vertically, and the factor is 1/9. You also, because of the negative in front, you have a reflect across the x-axis, and then we have, it says down or up. So we'll look at the end, and it says plus 10, so that means up by 10. And then we have x minus 2 underneath the radical, so that's going to be a right by 2 units. So here's your g of x, it says 4, and then cube root of x plus 5 minus 7. So first you have the 4 out in front, so that's a stretch vertically by a factor of 4. Any numbers in front are vertical, and then again, because it's 4, it's going to be a stretch. And then at the end you have a minus 7, so that's going to be a down 7. And underneath the radical you have x plus 5, so that's going to be a left by 5 units. Number 19, we have the 1/8 is underneath the radical, so that's going to be a horizontal stretch. And because it's 1/8, you're going to take the reciprocal, which makes it a factor of 8. At the end, it says -5, so that's a down by 5 units. And then underneath the radical, it says x minus 1, so that's going to be a right by 1. For number 20, we're supposed to rewrite in exponential notation. So what we're going to do is we're going to rewrite the x, and the x already has the exponent of 3, but this root is a root 4, so that's going to make your fraction 3 over 4. So it's x to the 3 over 4. I kind of think of this as like a tree. On a tree, your roots are on the bottom, the leaves are on top, so this is the 4th root, and so that's why you put the 4 on the bottom, if you want to use the tree analogy. Over here you have a, b, and it's all going to be to the 1/3 power because the root is cube root, and again, like roots of a tree, the roots are on the bottom, so we're going to put the 3 on the bottom of the fraction. Problem 22 says rewrite in radical notation. So we have a to the j over k, and so again, you have j is the exponent, and then k is the root, so you leave a to the j, and then you do the k root of for your answer. We're going to do the same thing for 23. Again, this is the exponent and this is the root, so we're going to go 7th root of, and it's 5 squared. And then you can simplify this and write it as 7th root of 25. For number 24, be really careful because there's no parentheses. So that means that this exponent only applies to the y. So we're just going to leave the x out in front. And then as far as the y goes, the 3 is the exponent, the 5 is the root. So we're going to go 5th root of, and it's y cubed. For number 25, it says translate the radical expression into an expression with rational exponents, simplify if necessary. So for 25, this is a square root, so it's implied that there is a 2 right here on square roots. So what we're going to do is we're going to go 3, and then it's to the 8th power, and then the 2, because it's the root, goes on the bottom. So then you get 8 divided by 2 is 4, so you have 3 to the 4th power, and then 3 times 3 is 9, so 9 times 9 is 81. So your final answer is 81. Over here we have 7, 12 is the exponent, 6 is the root, so the root goes on the bottom, and then you can simplify that so you just get 7 squared, or 49. For 27, we're going in the other direction, so we're going to take our rational exponent and rewrite it as a radical expression. So because it's a 1/2, the 2 indicates the root, so that's going to be a 2 as your root of 16, but we don't usually write it like that. We usually just write square root of 16, so your answer is 4. For 28, you have 27 to the 2/3. You can think of 2 as the exponent, 3 as the root, so we'll go cube root, and then I'm actually going to write it this way. I'm going to go cube root of 27, and then write it as a power of 2. So cube root of 27, I chose to write it that way instead of putting the 2 underneath here because the cube root of 27 is 3. You still have the exponent of 2, so now you get 3 squared, which is 9. For number 29, now we're just going to simplify using properties of exponents. So you have common base numbers when you're multiplying and you have same bases. You're going to leave the base the same, and then you're going to add exponents. So we're going to go 3 plus 6. So you get 7 to the 9th power, and that's just how we'll leave it because that's going to be a really large number. Over here, for number 30, I'm going to fill in the exponent of 1 for y. And so what we're going to do is we're going to multiply the numbers. So -4 times 3 is -12. And then you have x to the 5th times x to the 3rd. So we're going to add those powers and get 8. And then for the y's, we're going to add those powers as well and get 7. For 31, we're still simplifying. So when you have a power to a power, you multiply. So it's 5 times 4. So you get 3 to the 20th power. And then on number 32, I'm going to fill in an exponent for the 5 because you have exponents to exponents. So that's still multiplying, but sometimes people call it shower the power just so that you remember to multiply exponents to exponents for all three terms that are in here. So we're going to go 1 times 2 is 2, 2 times 2 is a to the 4th, and 6 times 2 is b to the 12th. And we'll clean this up and write 25a to the 4th, b to the 12th. For number 33, I filled in an exponent of 1 on the 4, and we're going to shower the power. So this is going to be 4, and then you're going to multiply exponents. So 1 times -3 is -3, and then -2 times -3 is going to be +6. At this point, 4 has the negative exponent, so we're going to move it to the denominator of the fraction. So we're going to go x to the 6th over 4 cubed, and then finally we're going to simplify that and get x to the 6th over 64. For 34, we have -3, a squared, b to the 0, c to the -4. So I'm going to circle just b to the 0. Anything to the 0 power except for 0 is 1. So now you just have -3 times a squared times 1 times c to the -4. So we'll leave the -3a squared there. C has a negative exponent, so we're going to move it to the denominator. When you move it to the denominator, the new power is +4. For 35, I'm going to circle this x to the -5. The power is negative, so we're going to move it to the top. So you have -6, x to the 4th, x to the 5th, all over 18. So the 6 and 18 reduce. You just get 3 in the denominator, and then x to the 4th, x to the 5th, we're going to add exponents, so we get x to the 9th. For 36, we'll work on these 3's right here. They have the same base number, so we're going to subtract their exponents. So 9 minus 7 is 2, and then because there was more on top, so 3 to the 9th is bigger, we're going to go 3, and then again 9 minus 7 is 2, so that goes on top of the fraction. For the x's, we're going to kind of do the similar thing. You have 3 minus 2 is 1. Because originally there were more x's on top, you're going to leave x to the 1 on top. We're going to take this y and move it to the bottom. So you get y to the 4th and y to the 7th. And then we'll just clean this up. 3 squared is 9. X over, and then add those exponents to get y to the 11th. For 37, we're going to shower the power. So you get a to the 15 over b to the 21. For 38, you have the same base numbers, so we're going to add exponents. So we're going to go 1/2 plus 3/2. So that's going to make 4 over 2, which reduces to just 2. So again, when you have same bases, you leave the base the same, add the exponents, which we got 2, and then 3 squared is 9. For 39, we have the same base numbers, so we're multiplying, we're going to add exponents. So we're going to go 1/6 plus 1/3. You need common denominators, so we'll times this 3 by 2 on top and bottom. So you get 1 plus 2, which is 3. Leave the denominator the same, so you get 6, and then that reduces to 1/2. So you get 25 to the 1/2, and we'll simplify this further because the 1/2 power is the same as the square root of 25, which is 5. For number 40, we have a power to a power, so we're going to multiply. So when we multiply -6/7 by 7/18, you notice that the 7 and the 7 reduce, and then also the 6 and the 18 reduce, leaving -1/3. So you end up getting 27 to the -1/3. So 27 has a negative exponent, so we're going to move it to the bottom of a fraction, and then it becomes a +1/3, but you leave a 1 on top. And then finally, we're going to take the cube root of 27. So the cube root of 27 ends up being 3, so you get 1/3 as your final answer. For number 41, we have x's on top and bottom. So first I want to work with these two because they both have a denominator of 8. So we're going to do 5/8 minus 1/8 makes 4/8. And that's going to reduce to x to the 1/2. And then now we have same basis, so we're going to add exponents. So we're going to go 1/4 plus 1/2. So we're going to go, to make the common denominator, we're going to go times 2 and 2. So you end up getting 1 plus 2 is 3, and then you leave the denominator the same to get 4. So you have x to the 3/4. For number 42, it's a square root, so we're going to break 12 down. So 12 breaks down to 2 times 6, and then 6 breaks down to 2 times 3. So you get 2, 2, and 3. Next, I'm going to break the a down to just a times a. And then for the b, it's b to the 7th. So because there's an implied 2 right here, we're going to ask ourselves 2 goes into 7 how many times? And the answer is 3. So that's going to be your exponent. So we're going to go b to the 3rd and b to the 3rd. And you write them twice because it's a square root. But there's also one b left over. That total makes b to the 7th. And then you also have c. So finally, we're going to pull things out in pairs because it's a square root. So the 2's come out. When they come out, it's just 2. The a's become a. B to the 3rd. And then you just write the square root of what's left. So if we break down 27, 27 is 3 times 9. 9 is 3 times 3. So we're going to write 27 as 3 times 3 times 3. Next, we're going to say 3 goes into 9 how many times? The answer is 3. So that's going to be your exponent. And you're going to write x cubed, and you're going to write it 3 times because it's a cube root. And we'll do that one last time for the y's. 3 goes into 4 once. So that's your exponent. And you're going to write y to the 1 3 times again because it's a cube root. But then you have 1 left over to make a total of 4 because you always need this expression to be equivalent to that. And now we're pulling things out in sets of 3's. So these guys come out and turn into just the number 3. The x cubes come out and become just x cubed. Same thing for y. And then you write what's left, which is cube root of, and the only thing left is just this y. For 44, we're going to rewrite this fraction as a big square root. A to the 11, b to the 9th, over a to the 7th, b to the 1. And we're going to simplify. So a to the 11 and a to the 7, we're going to subtract 11 minus 7 and get a to the 4th. For the b's, we're going to go 9 minus 1 is 8, so you get b to the 8. There's nothing left in the denominator. And then finally, now this is a square root. So we're going to do this again. We're going to break down. So 2 goes into 4 twice. So that's the exponent. So we go a to the 2nd, a to the 2nd, and you write them twice. And then we do it again. 2 goes into 8 4 times. So that's the exponent. And you write it twice because it's a square root. And now you pull things out in pairs. For 45, we're going to do the same. Because they all have a 4th root, we're going to rewrite this as one big 4th root problem. So now we'll reduce, and the 12 and 6 reduce and leave a 2, so you get 2 times 8. And then we can just break this down. The 8 breaks down to 2 and 4 and 2 and 2. So you get 3 2's, and you pull them out in a set of 4 because it's a 4th root, so they all come out and your answer is just 2. There's nothing left underneath the radical anymore. 46 says to solve the radical equation and check the solution. So to solve the equation, it's a square root. We're trying to solve for x. So we're going to square both sides. And by squaring a square root, they undo each other, so you're just left with x minus 3. On the right side, you get 16. And now you have a nice linear equation. You're going to add 3 to both sides, so you get 19. And then to check your answer, what you do is you take this 19 and you plug it in. And you're going to verify if in fact equals 4. So 19 minus 3 is 16. And it checks out because the square root of 16 is 4, so 4 equals 4. So 19 is your answer. First step on number 47 is we're going to subtract 12 from both sides. So you end up getting negative 5. Now we're going to divide both sides by negative 1. So what we've just done is we isolated the radical. Again, we got the radical all by itself, and now we're ready to square both sides. So we're going to square both sides of the equation. The square root and square cancel each other out, so you get x plus 2 equals 25. And then last step, you're going to subtract 2, so you get x equals 23. So to check this answer, we're going to take 23 and plug it in for x, and just double check that you do get a true statement. So you get 12 minus the square root of 25, and you get 12 minus square root of 25 is 5, so 12 minus 5 is 7, and it checks out. So that means that x equals 23 is your answer. For 48, the square root is already by itself, so we're going to square both sides. And the square root and square cancel out, so you just get 21x plus 1. On the right side, because this is a binomial squared, you're going to FOIL. So what's happening is you have x plus 5 times the quantity x plus 5. So when we FOIL that out, you get x squared. Your outer is 5x and your inner is also 5x, so when you combine those, you get a total of 10x. And then your last is positive 25. So now we have a quadratic equation, and I want the quadratic equation equal to 0 so we can finish solving it. So you're going to drop down this x squared. We're going to subtract 21x over. So when you do that, you end up getting negative 11x. And then we're going to subtract this 1 over as well. So you get positive 24. So now we have a quadratic equation we can solve. So we're going to factor it, and we can use a t-chart. And then finally, I'm going to show the work for the check. For 49, we have 3x plus 10 all to the 1/2 equals 8, so we're going to square both sides. The 1/2 and the square, they cancel each other out, so you just have 3x plus 10 equals 8 squared, which is 64. And so now we have a linear equation. Divide both sides by 3. And then we're going to check that answer.